All right, so our blood typing lab that we're going to run today is going to allow us to check 3 samples of blood. We're going to take them from patients that we're just calling W, X, and Y. Those are actually labeled on a template underneath this well plate, W, X, and Y. And I actually have my blood samples, these are not real blood, W, X, and Y set up just so that I can make sure I'm keeping track of who's who here. And I have on top of my well plate 2 anti-serums, anti-A and anti-B. These are mimicking what antibodies would be doing inside of your body. Remember, antibody A will attack, recognize and attack the A antigen on the surface of a red blood cell. Antibody B will recognize and attack the B antigen on the surface of a red blood cell. So what we're going to do is place a drop of each of our blood samples, patient W here and here, patient X here and here, and patient Y here and here. The reason we need 2 columns of blood and not 1 is that if I'm going to test for these antigens, these proteins on the red blood cell surface, I need to test for both the A antigen and the B antigen independently. If I tested them together, I wouldn't know if I had a reaction, whether it was to that A protein or the B protein. So we're going to run both of them. Let me just take a moment and fill all the well plates. You'll see me when I'm done take 3 toothpicks. So we need those in addition to our serums here in our well plate. I'm going to use one end of the toothpick and then the other end of the toothpick just to mix those around. It'll take about a minute, maybe 2, for any reaction that might occur to occur, and then we'll interpret the data. So just a drop or so of each. Doesn't take much. This is called microchemistry. We can use small amounts and still get the data that we need. And what I'll be looking for in the well plates when we're done is any sort of sign that a chemical reaction has occurred, because if my antibody attacks my antigen, my surface protein, a reaction will be occurring of some kind, and it usually causes the blood to gum up or precipitate. So we look for clotting, any sort of coagulation. We look to see if the liquid's gotten thicker. We might have to lift the plate up and tip it back and forth to see if there's any gelling or anything like that. So I drop down this column of anti-A, a drop down this column of anti-B. Going to give them a stir. Make sure you flip the toothpick in between so that you don't get any cross-contamination, just to be on the safe side. And then we're going to look to see again if anything has happened in the well plates as far as thickening or precipitation goes. And I can see already, I don't know how well I can see it on the video, there is a little bit of precipitation, so some solid falling to the bottom here. There's a little bit of thickness here. These two look the same that they did when I started. This one, if you lift the plate, you can see that it is much thicker than the one to the right of it. See how it's not running as quickly? So this is definitely thickening. This one looks the same to me too. So I'm going to say that this is a positive reaction. So I have some clotting here and here. That's patient W. Patient X, I don't see any clotting in either. They look the same to me as they did when we began. And patient Y, I would say clotting on the left here in the anti-A column and no clotting in the anti-B column. So there is your data.